Hello and welcome back to this tutorial series on Introduction to MATLAB. In the last tutorial, I discussed how to change color and line style of a given plot. Next, I am going to discuss how to create and change the marker style in the plotted figure. Let's get started. First, we are going to create a new script file. So simply click on new script and a new script file will open. Now we have to save this script file. So I am naming this file as script_4.m. After saving this script file, we will start writing our some basic commands. So first I will write clc clear to clear the command window and the workspace. Next I will create a vector x which start from 0 and with the increment of 0.1 goes up to 2 times pi. I will use semicolon to suppress the output. Next I will create a y vector which contains sign of x. Now to plot the figure, first we have to call this function figure to tell the MATLAB that we are going to plot a figure. After that we will call the command known as plot and then we will supply these vectors x and y. Next, what we did in the last tutorial is to give the color and line style. We use single quote and then we supplied the color which I am taking as a red, and then to change the line style we use double minus to create the dashed line in the plot. Now we have to save this file. You see a star is appeared, that means this file has been modified. So we will save this file and click on run. Once you click on this run button, a nicely plotted sine curve with dash line will appear with the name of figure as figure 1. So by default MATLAB gives the figure name as a figure 1 and we have this horizontal axis and vertical axis because we have not put it the x and y label, so we are not seeing any label on this axis. So let's change this graph little bit and put some labels. So I'm writing x label and y label. Also let's put title of the graph. We know that this is the plot of sin x, so let's write sin of x. Now save this file or simply click on this run button. It will automatically get saved and you will see now we have a nicely labeled graph of sine. But we have to do or create some marker styles on this sine curve. So to do that, let's look at what are the different marker styles available in the MATLAB. So you see here we have color, line style and marker type. So these are the different colors that are available in the MATLAB. So you can use these colors to create whatever color of line you want. Next, you can change the line style by using these options that are available here. So these values are used to create different type of lines. If you want to create solid line, use single minus. If you want to create dash line, use double minus, and to create dotted line use this colon operator, and for dash dot use minus dot. Next we have to see what type of marker styles we can create. So these are the different options available in the MATLAB to create the marker styles. So if you use plus symbol within this single quote, you can create this marker of plus mark. If you use this O, then you will create unfilled circle, and similarly you can use asterisk, cross symbol, S symbol to create unfilled square, D for diamond, and this upper arrow which is similar to the raised to the power to create the upward triangles. So let's use one of them to create our plot with this marker styles. So I'm using O symbol to create unfilled circles. So let's change this line of plot x comma y. So first we supply the color, then we use this line style, and then we use the marker styles. So remember this syntax here. First we supply the color, then this line style, and finally we supply this marker style. Now we simply click on the run button. This file get automatically saved and we will get this nicely plot of sine with this marker styles of unfilled circles. Next thing you will notice in this curve that sin x goes from -1 to 1. So this is our y axis, so it goes from -1 to 1. But on the x axis you will see that our curve ended up to this point, equivalent to the 2 pi. So you see x value is 6.2, which is approximately 2 pi, and y is -0.0830894, which is approximately equal to 0, not exactly 0. One thing you will notice here that this extra space is available on this axis, which is not utilized. So what we can do is we can put an axis limit to create the graph up to the within given range. To change that, let's close this figure and start writing after title or after plot. So now what I'm going to do is I am going to put a x limit and y limit to restrict our axis within the given range. So to restrict the x-axis we use x limit and then use this index bracket to call this function which is x limit, and now we will use these square brackets and supply the value from 0 to 2 pi. This means the first index means the lower limit and the second index means the upper limit. This way we restrict our x-axis. We will see when we plot it. Similarly, we can restrict our y-axis by using this y limit, and we will supply our value -1 which is the minimum value and the 1 which is the maximum value, that means lower limit and upper limit. Once you change these two command lines, save this file or simply click on this run button, and now you will see that our figure now has only sign plot with no extra space. So we start from 0 and goes up to the 2 pi, and its value in the y-axis is -1 to 1. So this way you can restrict our x and y axis limits using the lower limit and upper limit. So with this I have covered how to plot 2D graphs in the MATLAB. Next I am going to cover how to plot the 3D plots in the MATLAB. So to do that, let's move to Home tab and start creating our new script file. So let's write our simple command clc clear. You can save the file earlier or you can save it later. So let's save this file using Ctrl+S, and now I am naming it as script_5.m. Just simply save it. You know that in 3 dimension we need x, y and z 3 vectors. So let's create our vectors. So x is equals to 0, start from 0, and with the increment of 0.1 goes up to the 10. So this is my first vector. Next what I'm going to do is I'm going to create y vector which is 2 times of x. Next is my some z function which is the function of x and y. So I'm going to create this as, let's suppose, x square. I'm just picking any random number and we want to each and every element square, so I will use this element wise operation. So to do that, what we have to do is we have to use this element wise operation. Then I will use plus y dot power 2. Let's create this vector. So first I'm going to run this script files and I will tell you some of the important thing here. So if I run this file, you will see that x, y and z are of the same size. You know that you can use workspace to know the size and value in it. So if you look at the values here, you will see that x, y and z are of the same size. That means one row and 101 columns. In MATLAB, to plot the 3D plots, what we have to do is this z should be a matrix format. So what we have to do is I will change one of this x vector or y vector. That means I will take transpose of that. So to do the transpose of this, there is 2 ways. One, we can call transpose here by using the command known as transpose, and then I will supply these values in between these. Benefit of this will be that now this is a row vector, that means it has one row and multiple columns. By using the transpose of this, y will change to the column vector. Now if I run this command here or run the script file, you will notice here that now z is a matrix which has 101 rows and 101 columns. Now what we can do is I will call the figure, and now to plot in 3D we have options available. So first I'm going to call known as surf plot, which is short form of the surface plot. What we have to do is we have to supply x, y and z to it, and let's save this file and simply click on run. Here we go. You will see we get a 3D plot, and you move to this figure here, you will see this circle option, which by clicking as a left click you can rotate it in whatever way you want. So you say this is a 3-dimension surface. So using surf command we can plot this 3 coordinates x, y and z. So this is the first coordinate, this one is the second coordinate, and this one is the third coordinate. Simply we can put labels here. So I will call x label as x, Then I will use y label as y, and then I can put z label now as z. Now we simply save it and click on this run button to create this nicely 3D plot. So you see here that this is our x plot. We start from, this is x-axis, so this start from 0 and goes up to the 10, because we created a vector x which start from 0 and goes up to 10. And if you see in the y, we did 2 times x, that means it should go from 0 and goes up to 20. So it start from 0 and goes up to 20. And if you look at the z, it start from 0 and goes up to the 500, because we have created x square plus y square. So this is how you can use 3D plot. One of the 3D plot I discussed is known as surf plot. If you move to this plot tab here, there are some other options available, such as contour plot, which is again beneficial to create 3D plots in 2 dimensions. This surface plot is useful to create in 3-dimensional plots. And this one, another one is the mesh plot, which you can use to again see in the 3 dimensions. This one, contour plot, is useful to see the result in a 2 dimensions of 3-dimensional data. So this was all about today's tutorial. Thanks for watching this tutorial. I hope you like this, and please like, share and subscribe. I will see you in the next tutorial.